This video is about vector application, and I'm just going to jump into a bunch of examples right from the book. So let's look at number one. It says, an athlete can normally run with a constant speed of 6 meters per second. So this is his speed here of 6 meters per second. Using a vector diagram to illustrate each situation, I want to find the athlete's speed if he is assisted by a wind of 1 meter per second. So he's being assisted by another a wind from his back of 1 meter per second. So his resultant vector then is going to be 7. It'll be 7 meters per second. The next one, it says he runs into a wind, a headwind of 1 meter per second. So his speed is 6 meters per second, and we have the headwind of 1 meter per second, which means then that his resultant vector here is 5 meters per second, 5 meters per second. There you go. Let's look at number 2. So in still water, Mary can swim at 1.2 meters per second. She is standing at point P. This is my starting point. We're going to start here on the edge of a canal directly opposite point Q. The water is flowing to the right at a constant speed of 0.6 meters per second. If Mary tries to swim directly from P to Q without allowing for the current, what will her actual velocity be? So she thinks she is swimming across the river at 1.2 meters per second. And then we have the current of 0.6 meters per second. And then our resultant, when we add both of those vectors together, we end up with this resultant vector here. Now this turns out to be a super easy problem because what I have here is a right triangle. What comes to mind with the right triangle is the Pythagorean theorem of a squared plus b squared equals c squared. The a and b are interchangeable because we're adding them, so we'll just plug these in. So I have 1.2 squared plus 0.6 squared equals my magnitude squared. And if I want to know, I don't want to know magnitude squared, I want to know magnitude, so I'm going to square root both sides. And so I'm just going to throw this into my calculator to find out what the magnitude is. So I have the square root of 1.2 squared plus 0.6 squared, and that gives me 1.34. My magnitude is 1.34 meters per second. So there you go. The next one says Mary wants to swim directly across the canal so I want to go from P all the way to Q, which means that I need to adjust for the current. So this is my resultant vector of just swimming directly across. We already know that she's going to have to swim in some, we still have this vector here of the current of 0.6. And so she needs to swim diagonally here in order to get the resultant vector. Now, we know what this diagonal vector here is. This is what she thinks she's swimming, which is 1.2 meters per second. And then what does it want us to find? It says that I need to, at what angle should she aim to swim in order that the current correct to her direction? So I want to know what theta is here. Well, if I want to know what theta is, and this is another right triangle, then what I have is, I can just use my trigonometric ratios. Opposite over hypotenuse, that's sine. So I have sine theta equals 0.6 over 1.2. To get theta by itself, I take the inverse of sine, so that gives me theta equals the inverse of sine of 0.6 over 1.2. We'll just throw that into our calculator. So I have the inverse of sine of 0.6 divided by 1.2 to get 30 degrees. So my theta is 30 degrees. I need to correct 30 degrees. So I suppose that would be what west. That would be west of south. And then what will Mary's actual speed be? So I need to find the magnitude of this. So in this case, I want to find the magnitude here. Again, we're going to use the Pythagorean theorem. I have m squared plus 0.6 squared equals 1.2 squared. I'm going to subtract 0.6 squared from both sides. That gives me the magnitude squared equals 1.2 squared minus 0.6 squared. Then I'm going to take the square root of both sides, and that will tell me that my magnitude is, I'm just going to throw this into my calculator, the square root of 1.2 squared minus 0.6 squared. Shoot, I went too fast. And that gives me 1.04. So my magnitude is 1.04 meters per second. Okay, so number 3, a boat needs to travel south. So I need to travel south at a speed of 20 kilometers. So this is my resultant vector at 20 kilometers per hour. And it says, however, a constant current of 6 kilometers per hour is flowing from the southeast. So that would be a vector that looks like this, of 6 kilometers per hour. And then it says here to use vectors to find the equivalent speed in still water for the boat to achieve the actual speed of 20 kilometers per hour. So I'm going to try to find out this, which doesn't really happen, other than I do have an angle here, and I also have a speed in that direction so that I can get this resultant vector of 20 kilometers per hour. So I'm going to try to find out what this magnitude here is. Now, looking at this problem, it feels like there's something missing. It feels like I have two sides. We know that in order to figure out all the other sides, we need either side, 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 or side, angle, side, or angle, side, angle, or angle, angle, side. Those are the possible the possible sides and angle configurations that we need in order to figure out everything else. But by inspection, if I know that this current is flowing from southeast, then that means that this angle here is 45 degrees, which would mean that this angle here is 135. I don't know if that's, maybe I should have just pointed that this is 135 degrees. So now we can use the law of cosines. So you recall law of cosines is a squared plus b squared minus 2ab cosine c equals c squared. And the a is always opposite, this length a is always opposite angle a, b is always opposite angle b, and angle c is opposite of length c. So that means we're going to make this angle c, which means this is length c. And so a and b, they are interchangeable because we're adding them. So I have 20 squared plus 6 squared minus 2 times 20 times 6 times cosine of 135 degrees equals my magnitude squared. Now I don't want to know the magnitude squared, I want to know the magnitude, so I square root both sides and then throw this whole mess into my calculator so that I have the square root of 20 squared plus 6 squared minus 2 times 20 times 6 times cosine of 135 degrees, and that's going to give me 24.6. My magnitude is 24.6 kilometers per hour. So, so there you go. We have, it's 24.6 kilometers per hour. Next one says, so we also have to use the vectors to find the direction in which the boat must head to compensate for the current. So I want to find this angle right here. Well, let's just use the law of sine. So I have sine of angle theta over the length of the opposite side, which would be 6, equals sine of 135 over the magnitude, the opposite length, which would be 24.6, I'm going to multiply both sides by 6 so that I get sine of theta equals 6 times sine of 135 over 24.6. I then take the inverse of cosine, so I have theta equals the inverse of cosine of the 6 times sine of 135 over 24.6. And let's throw that into our calculator to find out what that angle is. So I'm going to take the inverse of sine of 6 times sine of 135 and then divide by 24.6, and that gives us 9.93. 9.93 degrees east of south. All right, so let's not make this video super long. I'll skip to number 5. It says an airplane needs to travel, or it needs to fly due east. I need to fly due east. So that means that my resultant vector is going to look something like this. And then due east from one city to another at a speed of 400. So we're going, this should be 400 kilometers. However, a 50 kilometer hour wind blows constantly from the northeast. So from the northeast, we have this vector here of 50 kilometers. And so I need to figure, so how does the wind affect the speed? So we're trying to figure out what this, the magnitude of this vector is right here. And again, it feels like we're missing a lot of information, but there's something really telling here. The wind is flowing from the northeast, which means then that this is a 45-degree angle, which means that this angle right here is 135 degrees. So again, we can use the law of cosines of our a squared plus b squared minus 2ab cosine c equals c squared. So let's just jump into this. I have 400 squared plus 500 squared minus 400 times 50 times cosine of 135 degrees equals my magnitude squared. And then we take the square root of both sides, so to get magnitude by itself, and we'll just throw this into our calculator again to find that we have the square root of 400 squared plus 50 squared minus 400 times 50 times cosine of 135 degrees, and that equals that our magnitude is 420 kilometers 420 kilometers per hour. Let's just make sure that we did this all right. Oh, I forgot the minus 2. I forgot. See how we have a negative 2? I forgot the negative 2. Silly mistake. I did that on the paper as well. I'll just throw this in. We have 2. So we end up with a magnitude of 436 or 37. We could say, let's just do 3 significant digits. So our magnitude is 437 kilometers per hour. That silly mistake. I was getting a little sloppy. There should have been a 2 right here. So I think what would have helped me avoid this mistake is if I actually wrote this out of a squared plus b squared minus 2ab cosine c equals c squared, so that I didn't forget that little 2 there. So there you go. That's the answer to A. Let's look at B. In what direction must the airplane head to compensate for the wind? So I'm trying to figure out what this angle here is. So let's just use the law of sines again. So I have sine of theta over 50 equals sine of 135 over n. We know what m is. We'll just throw that in here. We have 437. I'm going to multiply by 50 to both sides. It gives me sine of theta equals 50 times sine of 135 over 437. And then we take the inverse of sine of all of this, 50 times sine of 135 over 437 to get, I'll just throw this into our calculator again, the inverse, oh shoot, I made a super mistake, I should have just hit trig, and then the inverse of sine of 50 times sine, oops, sine of 135, and then divided by 437, and that gives us 4.64. So I have theta equals 4.64 degrees north of east. That would be north of east. So there you go. I hope this was helpful, and I hope you have a wonderful night.